Welcome back. In this video, we'll be graphing inequalities, so systems of inequalities, like, for example, y is greater than negative 2x minus 5, and y is less than or equal to x plus 3. So we're just going to go ahead and graph this. You can put this on your calculator, but you're eventually going to have to transfer it to the page. And for lines like this, I don't even think you need to use your calculator. If you're wondering why there are bunny ears on this graph, it's just to make it look a little less intimidating. So we can treat this as y equals negative 2x minus 5, so negative 5 is the y-intercept, minus 2x, go down 2 over 1. This is our graph. Now notice, this is y is greater than, it's not greater than or equal to, so when we do this, we have to draw a dotted line, like so. And this is going to be our graph. So let's do the other one, x plus 3. This one is less than or equal to. The equal to means we can have a solid line. Now we need to find our solution set. So y is greater than this graph. So that means y is above that line. So it's here. We get a different color for this actually. So this one, the solution is here. And for the other one, it says y is less than the graph of x minus 3. So where it's less than is going to be here. And so in the middle here, where my highlighter has turned green, this is going to be the solution set. The place where y is greater than negative 2x minus 5, but less than x minus 3. Alright, let's try another example. Let's say 2x plus 3y less than 6, and y is greater than or equal to negative 2/3 x plus 4. Okay, I'm going to put this top one in slope-intercept form, so subtract 2x, then divide by 3. So we get y is less than 2 minus 2/3 x. So let's graph that. Let's start with this first equation. So the y-intercept is 2 and negative 2/3, so down 2 over 3, down 2 over 3. Draw my line. Remember, that's a dotted line because it's not greater than or less than or equals to, it's just less than. So we need to get a dotted line. Okay. And the next one, y is greater than or equal to negative 2/3 x plus 4, so we intercept at 4. Same slope as before, negative 2 over 3, down 2 over 3, same slope as before. And we have these two parallel lines. So now we got to actually fill in the graph where it is. So let's start with the top one. It says y is less than the graph of 2 minus 2/3 x. So where this is that graph, it's a less than that, so it's down here. And the other one says y is greater than or equal to the graph of negative 2/3 x plus 4. So it's greater than this graph. However, you've already noticed these two do not cross. These two lines do not cross. This means there is no solution. There's no place where both of these two things are satisfied. They never cross. So this is one where we say there's no solution. And one last example. We have y less than or equal to 3 and y greater than x plus 4. Absolute value of x plus 4. So let's start with y less than or equal to 3. This means that we go up to 3, dot, all the y values are going to be less than or equal to 3, so we draw a straight line across at 3, and let's go ahead and shade that in. So the places where y is less than or equal to 3 are down here. Go ahead and shade really well. Okay. This program just really hates me sometimes. Okay. I need to get a better one, which I will do. And the other one is y is greater than x plus 4, absolute value of x plus 4. So that's something you can type into your calculator if you want. I'm going to go ahead and do that. Just figure out what this graph is supposed to look like. So y is equal to the absolute value of x plus 4. And it's just a normal absolute value equation, but of course that plus 4 means it's shifted to the left 4, like we learned in previous lessons. So that plus 4 is that h inside there that's going to shift it to the left 4. So 1, 2, 3, 4. Draw our absolute value. This. And it says y is greater than the absolute value of x plus 4. So let's fill in all those places. It's greater than that graph. And our solution for this graph, the solution to these two equations, is once again that point right here in the middle where it turns green.